Welcome to today's community conversation, authoring generative design tools. This is part of the Dynamo office hours series of community conversations. I'm your community host, Sean Hurley, and we've got Jacob Saul and special guest Lilli Smith. All right, community conversations are virtual meetups featuring expert speakers from across the community. Sessions range from deep dives, tips and tricks, live demonstrations on products like AutoCAD, Revit, Dynamo, all those good things, to roundtables and industry insights. You can propose your own, by the way, and I'll give you a link later on about that. But they go from all experience, from beginners to experts. So the fun stuff, Jacob.
There's too many windows. I can't do my usual shortcuts. This is killing me.
All right, the lawyers make us read this. If we make any forward leading statements or talking about future things, we can't make any promises. Make your purchasing decisions based on the products as they're shipping today. That's all this is. Some fun ground rules and norms. Some things have changed here. Of course, we're in webinar mode, but your line is muted to reduce background noise. The camera, we don't have the camera in webinar mode. So I need to update the script here to ask a question, asking the questions and answers, and you can see everybody's questions in full transparency there. You can still ask in the chat, and if you really want to be, if you want to share a screen or you want to bring in your voice, you can raise your hand and we can bring you to a panelist and you can talk. So there are a little bit of changes, but I think we got more expanded opportunities. This session will be recorded, and a link and the recording will be posted to the event page where you registered, as well as on the YouTube Dynamo Office Hours playlist. Next, please. I'm Sean Hurley, Autodesk Community Manager and a geeky technologist located in sunny Bend, Oregon.
And I'm Jacob Small, an Autodesk technical consultant, Dynamo Forum junkie, based out of Boston, Mass, but at the moment reporting in from Stockholm, Sweden.
Hello, everyone. My name's Sol. I'm a product manager working on Dynamo. I describe myself as a curious human being, currently also based in Boston, where most of us are. Sunny outside, I hope, but I'm sitting in a cave right now with no windows. Glad to be here.
Hey, everyone. Lilli Smith. Thanks a lot for the invite to come talk today. I am a product manager working on generative design, Dynamo Player, and my short description to follow yours is architect geek. I love to go see architecture. I love to experience architecture and work on new ways to design.
Nice.
All right, so this is my contribution today, 2 slides and maybe 1 or 2 at the end. The bulk of the heavy lifting is going to be done by Lilli and Jacob. So today, this is session number 35 in our Dynamo Office Hours series around authoring generative design tools. It's going to be a good one, so get your pencils out, take some good notes. Looking forward to the journey. And as per usual, we have an agenda where we're going to cover around about a 15 to 20 minute presentation in a deck with a live demonstration afterwards, which is probably going to be a little longer today, and Q&A interspersed throughout with some dedicated section at the end. So as always, this is a conversation. Please do interrupt us, ask questions, raise your hand, do all that good stuff, and ask all those hard questions. We're more than happy to answer them.
All right. So one thing to say before we get going, since this is part of a larger series on generative design in particular, it's really tough to fit this all into, this is a really big topic, so definitely doesn't fit all in 1 hour. So we've got a whole bunch. So I wanted to make sure we talked about last time on Dynamo Office Hours before we get started. So last week we had, or 2 weeks ago, we had John Pearson, who is in the chat. Hi, John. Come in and sort of talk about, and this is the big key takeaway. He highlighted it for me. I didn't even have to go looking for it. If there's one thing to take away, it's that generative design is not magic. It requires you to build the logic out in Dynamo. right? I really wanted to drive this point home because it isn't magic at all. It's, you know, just a sufficiently advanced technology which makes you think it is magic. So similar to BIM and other tools, generative design is going to take some work. You're going to have to make it happen. It's not just going to happen automatically, right? Everybody who's of a certain age remembers transitioning from AutoCAD to Revit, or if you're a little bit older, you might remember transitioning from the drafting tables into CAD, right? All of that stuff kind of is a transition that's going to take some effort to get there. And generative design is no exception. The work happens in terms of defining the logic and those routines in Dynamo, but it's also important. Do not forget your adjacent applications. If your adjacent application data is no good, you're gonna be generating some no good generative design results. So you kind of have to have a good foundational skill set in both to really excel in this space. Also important is knowledge of the problem that you're solving. If you've never solved the problem before by hand, you are going to struggle mightily if you just try and jump in and say, yeah, I've never designed a skyscraper before, but let's figure out how to do a crazy twisty tower generatively, right? Not going to work out well for most people their first time out. And then generative design tools, like any other tools, if you think back to your Revit families, your Revit templates, your Revit files, your CAD files, etc., all these things are going to progress over time. You're not going to have one file that you're going to build and never have to go back and author. So keeping those that foundational skill set in terms of how to build and manipulate Dynamo graphs is really, really important because you're going to have alternative generation methods come up, expanded outcomes. Hey, this job cares more about this than the last one that cared about that. So let's figure out how to calculate this thing, and addressing edge cases that might come up. What if your site is super narrow and therefore none of the offsets that you're using before sort of work because we've got these crisscrossing polygons? How are we going to sort of deal with that stuff? So all of this stuff does take some work. But we wanted to make sure that we had sort of an idea about how to get started with a generative process. And that's why we brought Lilli in today. She's an absolute expert in this piece. So Lilli, I'm going to turn it over to you. I'll be flipping through the slides, but we're going to go ahead and talk about how to get started with generative.
Great, thanks, Jacob. I think a couple of weeks ago when the first generative design talk was, I was bouncing around in Europe, did some traveling over there. So hi to my friends in Amsterdam and Germany. I love your cities, they're fantastic. And never been to Copenhagen, but it's on my world bucket list. So I have a background as an architect, and I have been working on this problem of generative design with Jacob and Sol and others for a couple of years now. So we wanted to, I know last session, John gave you a great overview of looking at some problems with laying out some trees and how you could use that in Dynamo Player, and then how you could go and transition to using that in generative design. I think that was a great intro to these tools. We're gonna we'll repeat some of what he went over last week, but we're really gonna go through some concepts on, you know, what do you need for a generative design study, and how do you start to go about it? And I would say first that the process really isn't super different from what you might do as a traditional designer, right? So you need to understand the problem that you're going after, define it very clearly, decide ways to measure success, think about how you're going to review the results. If you want to go, and so you're working with people, right? Figuring out what the parameters are for your design problem. Next slide. So this is a kind of the process in a nutshell. So there's definitely people involved on kind of both ends of using the computer to help you generate a lot of options that you're going to look at and keep track of them. But people, very important in the beginning to define the concept, the constraints, and the goals. And that first chunk is what we're going to cover today. Then we're going to go off and let our computers run for a while, and we'll come back in the next episode and talk more about like the evaluation piece and how we can use the results that the computer has given us. I can go to the next one. So yeah, so I love Daniel Nagy used to work at Autodesk in Autodesk Research, and he has a great blog on Medium talking about generative design, and he's actually talking about it on using Grasshopper. But a lot of the concepts are, you know, very similar to what you can do in other parametric systems as well. And he really gives a lot of great background into what this method is all about and how to think about a lot of different concepts in it. So I encourage you to read that. But an important quote that he says is that the goal of the generative design is not to automate the design process or take human designers out of. They're very, very important in how we define this. So a lot of people get scared that we're like taking away their jobs. Not true. Just changing it to a different way of thinking, I think. So, okay, we're going to look at a specific design problem today. And this is a site that we have in Boston. And our client has asked us to design a world-class building. Some of these things are more quantifiable than others, but that has good views, as much open space as possible at the street level. It maximizes our rentable space because we want to have as much income as we can. And it also minimizes the amount of facade that we have because the facade materials are really expensive. Maybe they are things that have a lot of embodied carbon. We want to minimize them. So that's our design problem. And we have, if you go to the next slide, so we've done some work in figuring out how we're going to approach this problem already. And we have a notion of this tower here. And I'm just going to describe the basic way that we're thinking about how to shape this tower. So we have different parameters that are going to shape this mass in different ways. And this is just a specific design that we came up with because we liked how these angles worked in this site. And so there were some design decisions that we made. So if you go just one click forward, Jacob, you can see, so the black line that we showed was the site. Then this is our first idea of the massing, and this blue dot is kind of moving back and forth on the site, and it's bringing it back to make more resultant green space. You can see the green space in the model there on the right. So that's kind of our first parameter. We'll see how that's working in Dynamo. And then another layer on top of that is how we're going to split up the towers. So again, we have these points moving back and forth on a kind of derivative of the sight lines, and they're breaking up this form into these three towers that are critical part of our design that we're going to investigate what we can do with them. Okay, so these are kind of the summary of our parameters that we're going to vary in the study. So we have the heights of the towers. We have the corner point in the open space that we showed, that was the blue dot. And then the splitting location, the orange dots. And all of those parameters are going to be in our model as inputs. But if we take all of these 8 inputs and we just sample like 3 different choices on each one of them, that works out to 6,561 different design options. So you can go to the next slide. So we can use the computer to like generate a lot of design options. If we set it to more than 3 samples for each of those variations, it would be even more. But how does this really help us, right? Like, are we really going to go through all of these and just how are we going to make these choices? So the critical second half of the problem here is that we need to have some some metrics, some goals that we can use to help sort through these results. And I would posit that there are really 3 different types of measurements that we could do here. There's things with simple math. So we could, like, in our goal of having as little surface area as we can measure that pretty easily in Dynamo, because there's a surface area node that we can measure the surfaces with. We can add them all up. We can look at the heights and do some analysis with them with some pretty simple math. We can also use more complex nodes, things like solar radiation or some view analysis that uses rays that are going to measure how far it is to a different building. We could use those for more complex analysis. And then, of course, there's always going to be things that are not measurable that are going to factor into this, such as beauty, personal preference, aesthetic sensibility. And some of those things that we have already kind of made these design decisions and how we've set up this parametric model. And we can evaluate the results based on our own designer's intuition after the fact as well. But as much as you can put things into math, it's going to help you to sort through them. And we'll show an example too of how you can try to start to put some of these preferences into math. So yeah, you can go forward, Jacob. So these are the goals that we're going to come up with. So we're going to try to maximize open space. So this little green space on the bottom, admittedly kind of simple for open space, but it's a first go at shaping this building, right? We're going to try to maximize the floor area so we can get more rent. We're trying to minimize the facade area because it's an expensive material. And then we have one of the aesthetic choices that we're going to make is we're going to say that making the differences in the towers as much as we can is a good thing. And so we're going to figure out how to measure that. And we're going to say that we want to have as much difference as we can, because we think it's a more interesting dynamic building like that. And then we're also going to look at view quality and how those different heights and different shapings of the building are going to affect the views coming from the building. Let's see, what do we have? Okay, yeah, so this is, we might go back to this when we are looking at how to make this view metric, but this is the basic idea on how this is measured. So you can see on the bottom, there's design 1, design 2, design 3, and we're measuring the heights of those 3 towers, like what the heights of those 3 towers are, taking the average of them, or taking the difference between what the heights is and making that orange bar. So that's just measuring what the delta is between those heights. And then we're comparing those against each other and saying that the one with the biggest orange bar is the best design of how we're defining it, because we like a lot of difference in height. So we can look at how to do that. And then this is just showing how the view analysis is working. There's a node. This is part of the refinery toolkit, which you can get on the package manager, that has some nodes for doing massing, like convenient tools for working with massing analysis. And this is one example of one of the nodes in there that can calculate this site distance for you. And I just put some lines on the points to visualize how it's measuring. When it turns this pinky color on the bottom, it is hitting something that's closer, and you can see the site context there. It's hitting something that's closer. And then when it's up high and it's not in the orange section and it's not hitting anything, it's registering as a better view. Okay, let's see, what's the next slide that we got?
Next up, we go to the demo.
Okay.
Yeah, so cue the danger music. And while we work on switching over the slide, the screen share, I'll stop my sharing so you can pick up. I just wanted to talk in particular in the view metric, as Lilli mentioned early on, that's one of those more complex evaluations. So a lot of times you wind up having to deal with more abstract concepts in order to make it work. And it really helps out sometimes in terms of wrapping your mind around how that concept is working and doing stuff like let's visualize those vectors of the views from the points to sort of figure out what that means about that view direction from the given piece of the surface. So really glad to see that in there. Great add, Lilli.
Yeah, and so as we go, I'm going to show you this this model that we've made and kind of how to go from, well, how it works as a parametric model, and then kind of how to turn it into a generative design study, so that you can start to get those 6,000 whatever many options, and also how we can measure some of the results. So, and Jacob and Sol, Sean, feel free to jump in if anything doesn't make sense or you want to add color. That would be great. So the first thing about this model, and I think we can probably post this model if people are interested in trying it out themselves. There's a lot of good learning in this model. You guys can help figure out where to post this, but so the first thing is just to understand kind of what you're going to see in this graph. And we have these different sections with different color codes. We like to use, just because we do, pink for inputs. The functions are all in these green groups. Our outputs are going to be in orange groups. We have display functions, so turning on different parts of the model, in blue. And then integration, like writing stuff back into Revit, is in these gray groups. Okay, so first let's look at kind of how this parametric model is made. And I explained some of it with my silly PowerPoint point diagram, but just to show you how this is worked. So first we're getting this site input from Revit. So you can see down here in Revit is my site. And I built this in Revit because it's way easier to build the site context in a modeler like Revit. And you could just bring it in all with like one node, pretty easy. It's nice to get a start on this context. And I actually also built out this thing that you can see here in the middle is this zoning boundary. It's like a 3D zoning boundary. And that is coming into our model too. I don't think we're actually using it in this example for analysis, but you could turn that on and you could use it for like, okay, if I start rotating this model or building it certain ways, how much is going outside of the zoning boundary? But so just pointing out that Revit can, or something else, I think Jacob has some examples from Civil 3D, like starting with your context there and bringing it in can be a great way to like kind of get a head start and use these. We're going to use this context in this evaluation too. So we're putting this in a pink node and bringing in all our Revit stuff. So the first inputs I want to show you are this U and V. So this is just a matter of like how this is moving along this polygon that's representing the site, right? So if I have my model set to automatic, but if I start to move this in different ways, it's just going to move this point out and back, and it's going to start to change the shape of my building in a controlled way. So that is the first parameter. We also have this notion of, and again, looking at our diagram here. So that was this first cyan dot there. Now we're going to look at these like splitting parameters that we have. And those have 3 different parameters that we can flex again to change the shape of this tower. And these are just moving back and forth along the sight lines, giving us different ideas or different forms of the mass. The kind of third group of, so we've now we've seen 5 of our 8 parameters, and the remaining 3 are on these tower heights. And so this was a design decision in our is what are we actually going to vary in this study, and varying the height of each of these 3 ways that we're cutting up this form is something that we want to study, and whether what are the implications of having a lower tower on the north or a lower tower on the south. What are those going to give us in terms of our goals? One important thing to point out here is that the range setting is really important when you're working with generative design. So we can set a minimum value, we can set a maximum value, and we can set a step, or like how much we want it to change between clicks. And so that can really help our design space to be smaller. So you can imagine, if I set this to 1, I'm going to have 10 times as many possible changes in this range as if I set it to 10, right? But I want to set it to 10 because I want 10-foot floor to floor. So, okay, so we have, that is our inputs. Anything I forgot, Jacob? We're going to show how to put these so that they are register for GD inputs in a minute.
No, I think that's pretty good. The one thing that I would want to add at this point is we're sort of hiding a little bit of the work in that the nodes that are doing the actual creation of these bits of form are in these collapsed groups, which is a function of Dynamo 2.13. So if you're trying to follow along at home and you're in Revit 2022 and things don't quite look like this, and you can't figure out why, it's probably because you're in the older build, so you're going to have the gray nodes instead of the black, and you won't be able to collapse your groups to sort of hide the big effort in terms of all the different nodes that have to be placed. Again, this is looking at things more from the what do we need to know to get into generative, as opposed to how do we have to combine the nodes in order to get those results right now.
Yeah, thanks, Jacob. So yes, important to point out, I am using Revit 2023.02, I think, which is the latest Revit, and it has Dynamo 2.13. And yes, I love these collapse groups because I like to, look at this, like it's less scary with everything like collapsed up. Or you could say it's more scary because you don't know what's going on. But it's nice that it has, gives you these like really simple, like what are the inputs, what are outputs? You don't have to worry about everything inside there until you want to worry about it. So yeah, these green boxes are doing a lot of the work in there, in like getting the site outline, creating the mass outline, splitting it up, doing stuff like creating floors and the building volume itself. Okay, so let's talk now about how we're going to have this evaluated for our different goals. And just to look at one of the more simpler ones. So these are all in these orange nodes here, right? And to look at one of the simpler ones here, let's look at how we're going to calculate the total facade area. So we can open this up and we're getting in, and I try to also label things what they are, so that when you open this group, you'll understand, what this is that's coming into here. So vertical surfaces are only what's going into our calculation, and then we're just simply using this surface area node to, get a list of what all of our surface area amounts are, adding them up, and then that's what our facade area is. So that one is pretty easy to do. Calculating the floor area, also pretty easy. We just have to make sure to divide it into the number of floor to floor height, or divide it into the number of floors we want, measure the area again and add them up. And when when we're preparing this for generative design, we need to put the measurement of interest, in this case, the facade area and the floor area, into a watch node that is going to show up in our generative design study. And we are going to name this in something that it's going to show up in the generative UI. Same way the inputs also, like renamed sliders or number inputs, are going to show up with the name of the node in the generative interface. We can see that in a few minutes. Okay. I was going to show you how to build out the height differences, but I think I'm going to show you that in a little bit faster way because we are a little tight on time. And I want to get to where we're going to end up this with actually running it in generative design. So it's not a generative graph now, but we're going to change it into one, and we're going to run it and see some options. So this is how we are evaluating the height differences here. So we're just bringing in the heights of all of these towers, and kind of how I explained it on the on this chart here. Remember, we're trying to measure the deltas between the heights and then compare them. So we're just using some pretty simple math nodes. We're getting the average of all of the heights. So you can see that here. And then we are, if I get this to go down, taking the difference in those those operations, and setting the absolute value so we don't have any negative numbers, and then adding up those differences, and that's going to result in this difference in height score. And again, this is just one way that we're kind of trying to have some of our aesthetic choices be turned into something that we can measure with numbers. So we have a watch node here that we are going to be able to keep track of in generative design.
Yeah, and that idea of sort of taking the average and finding, what the sum of all the distances from the average is a very useful one in evaluating all different sorts of things. I was actually looking at what would the best route for a roadway or linear structure, a pipeline, let's say, through a landscape be. And that applies absolutely there as well as it does here, because you don't want too much variation in those surfaces, right? Unless you're designing a roller coaster, in which case you want to maximize that value, right? So all sorts of reasons to get into that. Again, it's still math. It's maybe more complex math than just what's the area of all the vertical surfaces summed up. But you're going to spend a lot of time when you get into generative sort of figuring out ways to do that, as well as trying to bound stuff between limits, right? Because if we've got values that are all over the place, we might really sort of skew some of our outcomes as a result of that. But back to you, Lilli.
Yeah. So I actually have another branch down here in this graph that talks about solar radiation, and I'm not going to show that today. And I actually have it frozen via this node, but because it's like a little bit slower for my demo purposes. But if you want to investigate this, you can totally turn this on. It's not that slow, and you can also use like more sophisticated solar analysis in your study as well. Okay, so now let's look at how we're going to convert this. We have our parametric model, we have our varying degrees of sophistication ways to measure how our designs are doing. And now we want to turn it into a generative design model so that we don't have to sit here and move these parameters, input parameters manually and just keep track of the results somewhere. It's a nice thing for the computer to help us do, right? So in order to change this into a model that will work with generative design, we need to tell it first that it's a generative design model. And if we go to graph status here. Let's see. Oh, sorry, graph properties. Wait, no, graph status. I had it right. It just turned off instead of on. It was already open and I didn't see it. Sorry. Okay, so graph status here. This is new to 2.13 Sol or 2.12?
2.12, I believe.
Okay.
Yeah.
So we don't have a lot of types in here. We only have generative design and none. But this actually is some functionality in Dynamo that has an API that if you want to write rules for your graph, you can take advantage of this. So we made it in a way that was open for other people that wanted to write rules for how Dynamo graphs should be. You can enforce them using this this functionality. So we're going to set it to generative design, and it's going to tell us how our graph that we have right now isn't meeting these rules that we have set in what is a generative design graph. And the first thing is that there haven't been any input nodes that have been set. So we have to have inputs and we have to also have outputs. So I am going to go in here and I'm going to change all the inputs that I want. So I don't need to have, I could have the Revit volume that I'm selecting as an input and expose that in the study so that you'd have to choose that in Revit every time. But for this purpose, I'm just going to leave it what it doesn't need to be variable in this study. I'm going to focus on setting other things. So I'm just going to leave that to be not an input. But all of these 8 different inputs that I said I cared about and was part of my design decision in making this study, I'm going to turn those on to be inputs. If there's a better way to do this than one by one, please y'all tell me, but you know, good to think about them, making sure everyone's do. But so, okay, so I have satisfied the input requirement. Now I need an output requirement. And I'm not going to do the solar, but I'm going to have the height delta, the open space, measuring my green space here, my facade area, and my floor area. So I'm going to turn these all into outputs. You can see that little warning went away, but there's other warnings that are cropping up here. Take a look at those in a minute. So, okay, so that gave me all of my inputs and outputs are set. And spoiler alert, when you get to 2.15, I think there is a graph node manager. You can see it right now on the if you go to the sandbox version, and it's going to be able to tell you what all your inputs and outputs are in the model, which is in one place here in this, which is really nice. But I don't have it in this version yet. So look out for that. But okay, so there's some other issues here that have cropped up, and it says the following nodes need to be cached using a data remember node. So what that is telling me, and it's giving me some graphics here, what that is telling me is that stuff coming from Revit is not going to operate when you're running this model kind of over and over in a separate environment, as Jacob was explaining earlier, right? And so we need to cache that information into the model, and it's telling me exactly where I need to do this. So I'm going to come in and I'm going to press this plus button, and it's going to put in a data remember. And it's also going to bring in this big 3-dimensional site boundary outline that I had in Revit. I'm just going to go and turn the preview of that off. But now it's going to be in there making my making the whole, you know, nothing would work in terms of my building geometry because I'm making it all off of the site without that. And I think actually there was, why is this one not working? Oh, there's another one, this view score over here. that needs to be an output. And so there's another data remember node that we need for this context. So we're going to bring in this context to do our view study. And we could use it for solar radiation as well. So we turn on that branch, but we also need to bring in all these geometry of this building that we've built in Revit and cache that in the model too. So that will work better. And we can also just go in and turn off this, turn off that preview. Okay, so we have set all of our inputs and outputs. We have fixed our remember nodes. There's one other thing that the linter, that's what we call this like generative design rule thing will do for you, which is when you are, this gray box here is writing data back out to Revit. So we actually have a branch of this graph that when we make a decision and we come to certain parameters, we can actually put this mass back into Revit and go from there. But the way we control, we don't always want to be writing to Revit, right? Like after every iteration, because that would just be mayhem for 6,000 iterations. So we have something called a data gate. And this basically controls the, we have a button in the Explore Outcomes UI that says create in Revit. And this data gate is hooked up to that. And so if you leave this open, it's going to tell you that you should have it closed so that no Revit, so we don't have total mayhem in the model. So we're just going to leave that as closed. And so our kind of workspace references, our extension here has been very helpful in getting us to make this into a generative design model. One other thing that it's doing that I'll show you is it is, sorry, I don't have my folders set up totally well here, but okay. So it's also creating, when I save this as a graph type generative design, it is making what it calls a dependencies folder in here. And this contains all of the packages that I have that I'm using in here, like the refinery toolkit. And it has any necessary files, like the weather for Boston is actually something that's being referenced in there, that it's packing up for me. And then definitions, I forget which that, oh, that's if I had any custom nodes, they would go in there. And
yeah, it's custom nodes that aren't in a package already. So DYF nodes that are not packaged.
The reason we did this was because we wanted people that didn't have all this stuff installed on their machine to be able to use this in their workflows. So if if I give this file here that I'm working on, this DYN file, which is now set to have all of its generative design qualifications, and this dependencies folder, if I give that to Sol, he's going to be able to run it even if he doesn't have any of these packages installed. And yeah, so you can, it's pretty handy to be able to use that. It will prefer package, if you're like just using this in Dynamo and you have all these packages installed, it'll use the ones that you have installed. It'll also ask you if you open the script in Dynamo if you want to install the missing packages. So that works, and we can talk about that more if people have questions. But so that's another kind of nice thing with having this graph type generative design. Okay, now I think we are ready to try to do a test run of this. So first we're going to save all of our changes, all of our input and output changes there. And we can actually, okay, that was scary. But we can actually run this right from generative design. So we're right from Dynamo. We don't have to go into the to the Revit interface. And actually, if you don't have an AEC collections license, this is also how you can, every Dynamo for Revit will have this already set up, ready to go. So you can create a study here. The only thing it won't do is let you select stuff from Revit. So we have, I forgot to show, like we've also added like a description here in the properties and this little thumbnail, author name, and URL with more information, so that when this comes up in this create study dialog, it's a little bit more friendly. You know what it is. You might know something about what it's going to do. Then if we to be able to set our inputs, and here we can see all of our inputs here, our height base, our north tower height, or south tower height, the parameters of the splitting parameters. And maybe I could give those more intelligible names, but they are what they are right now. And then the corner of the site, this point parameter here. So these are all checked, which means that they're going to vary. Now, when I'm in here, I could also make a decision that, well, I want the base to just be what it is. So I'm going to uncheck this, and I'm just going to keep it at 40. And so that's some of the level of kind of decision that you could make at when you get to kind of this stage. You can do a lot of messing around without necessarily having to go back and open up Dynamo. But so we're going to look at, I'm going to turn that back on because I said I wanted all those things to vary. And I'm actually just going to start by doing just a test run to make sure that this is going to work. And so we've tried to explain these generation methods a little bit better. But we have 4 different generation methods. And the one I'm going to choose first, just to test my graph, is this randomize. And this will let me just, instead of having to set all these goals and number of generations that I want to go through, it'll just let me set a number of solutions that I want to come up with. And for demo purposes, it's nice to be able to like set it a little lower. And I can just kick that off. Oh, I always forget to change the name of my study here, but this will start to generate options for us. And go ahead, Jacob.
What's happening in the background right now is Generative Design is spinning up 6 concurrent instances of Dynamo in a headless environment. So you've got that REST Dynamo core instance that would show up if you were to pull open the task manager. And those are going to keep cranking out results until it hits that cap that Lilli put in there at 10. So we're going to see results continue to run through. I think we've got 2 more coming as it finishes out. But to Lilli's point, the one thing I did originally unmute myself to say, don't forget to rename it. Oh, we hit the button too quick. I do the same thing like 6 times a day, only my studies are not like quick run of 10. It's usually like 100 by 100. And so I'm stuck twiddling my thumbs waiting for it to finish the first thing so I can.
Yeah, we really need to allow renaming this. Like, it's terrible. But I think we should probably get to questions. Are there questions?
There are no questions in the Q&A at this time, and we have been there has been some stuff going on in the chat, which has been pretty good about talking about what linter rules and stuff like that, as well as a few things about making no purchasing decisions around stuff that are future deliveries and stuff like that. But yeah, there's nothing at the moment. Oh, is there a way to change how many simultaneous Dynamo instances run? That's a great question, Lilli.
We have, many people have asked for that, and we have we do have that control, obviously, like in our development background, but we haven't exposed that as a user settable parameter. But yeah, it would, so no, we don't, but it's something that would be cool. And some people want it for just setting it to one instance so that they can do things like run a program that has a license that only allows you to run one thing at a time, like robot, I guess. Or they don't really care how long it takes. They just want to use that tool that will only let them run one instance at a time. Or people want to run 25 at once and speed it up for like really big studies.
Awesome. Yeah, good point. The other time I've seen it is if you had a crazy custom node where you wanted to run parallel optimization on that one custom node to get that one result faster, and having to rewrite that node for the generative design versus the non-generative design is a beyond time consuming, if I'm being honest with myself. So to being able to turn it down would be quite nice. Next question, again from an anonymous asker. What infrastructure is there for debugging during generative design runs? Is there any kind of a console or anything like that to say, like if I stop getting results?
We don't have a lot of tools, maybe you know more, but you can, I think, this is finished running now, but I think it has a pause button here when you're running it. You know, obviously, like you can look in Task Manager and see what's going on. I don't know, Jacob.
Yeah, I can talk a little bit about that. There is a log of that happens anytime you kick off actually opening generative design. A lot of times I'll see I opened generative design and then did nothing, and it just says, "Yep, generative design's open," like every 6 seconds or something like that. But in any case, there is a log that you can look into to see if there's any kind of bigger issues. A lot of stuff will be exposed there, like if the server's not running because there's some kind of an antivirus thing blocking it. The other key piece for debugging, so Lilli's been doing everything in the context of Revit, but generative design is going to run in the context of Sandbox. That's why we have to sort of remember that Revit data and stuff like that. So it often helps to just open the graph in Sandbox and see if you get results there. A lot of times it'll be instantaneously like, oh, well, duh, I missed a remember node there, right? And then you can go back to your Revit environment, put that remember node in and get your results. Because while the linter does catch most of those issues, it's not necessarily going to catch them all in all cases. So the capability to be able to do that, or find out, oh, I did have a call to the Revit API buried deep inside this Python node that the linter didn't catch, or whatever it might be. All that stuff can be really valuable in the Sandbox context. So I do always recommend it once you start getting into generative design, put the same matching version of Sandbox. You want to make sure you're using the same version in Revit as you are in Dynamo Sandbox, because things run a little bit different. You might have different nodes available or different sort of stuff happening under the hood, but put those on there just for the debugging purposes. And then one more question, because we're down to the last 4 minutes. Is the generative design calculations dependent on the CPU or GPU, Lilli?
I don't know, do you know?
CPU, yes. Yeah, and that's, again, if you pop that open with Task Manager, Barry, when you're running the graph, you'll see your compute when it's running will spike to 100%. And you'll actually see if you go into the details tab, you'll see REST Dynamo core instances popping up like crazy as you go along. All right, I'm going to take over screen share so we can get through our wrap up stuff. Thanks, Lilli. Maybe I've got a Q&A tab on top of my share window. There we go. Hopefully everybody's seeing the live demo slide that we are now past. So
we're good to go.
All right. So how can we learn more? Right. We put this in last time because, again, this is we're really getting to the deep nitty gritty in terms of what's available with generative design and Dynamo. So having handy links for where this stuff's available is definitely worthwhile. So the basic links are there. We will post this when we post the sample files for the graph that Lilli demoed today as well, up to the Community Conversations blog. All right, we already covered questions. So, apparently I messed up and stopped the screen share entirely.
We have a blank screen.
Maybe we lost the closeout slides somehow. Sorry about that, Sean. Give me
I can talk to a black page. It doesn't matter.
All right.
Just
Second
leave it to your imagination. The most amazing slides ever. Okay. All right. All right. Well, we're going to wrap it up with 2 quick slides with some helpful information. I'll paste it into the chat. As Jacob mentioned, we'll post stuff to the event page, the scripts and the model. If we get those from Lilli, that would be awesome. Thanks, Lilli. A lot of good information in there, a lot of good little tidbits to grab out of there about things that are coming that, make the lawyer wince, but all good. All right, so all right, well, anyway.
I only talked about things that are public, actually.
Yeah, no, I was just talking about in the chat where we were talking about things that might be coming. So I was just poking at Jacob, just having a good time. Anyway. You too can be a community conversation speaker. You can email me, and there is also a link to a form that I can put on the event page. So anybody that has any kind of experience in the industry or products, we would love to hear from you. If you have specific use cases, even a panel around generative design would be awesome. How people are solving things and take people's different live input and feedback on it. Be great. So, all right, everybody, thank you very much for joining us and bearing with us on the webinar, are dipping our toes into it. We do it because it's more scalable than the meeting mode where everybody just could unmute their mics. We still have that ability, but anyway, yeah, we get the little things floating up on the screen. That's anyway, thank you, everybody. There's a quick survey at the end. It does help us figure out what topics you'd like to hear in the future, things we can improve, things you liked. It's all good feedback, and it's really easy and quick. And thank you.
Yeah, and one quick thing to note before we leave, the next session will be Lilli, keep on going with this generative flow, and then we'll have a couple of live AU sessions with Jacob and Sean at Autodesk University.
Yeah. So yeah, we're gonna, next time is the punchline. We're gonna show what we're gonna do with the results. Why
awesome. Fun stuff.
Yeah, Lilli, you should come and join the session at AU too, if you get a chance. Give Jacob a hard time. Yeah.
Yeah, you got 2 options to come in and stump me, everybody. So looking forward. I'm also looking forward to getting to see Sean in person because we've been working together for a while and hasn't happened yet, man.
Well, I don't hear that very often. People looking forward to seeing me. But it'll be awesome. I can't wait. I'm excited, and we will be streaming that live. So for those unable to attend AU this year, you'll be able to attend and see the epic danger music live over stream. So
cool. All right. Well, thank you, everybody.
See ya.
Thanks, everyone.